Thank you, William. That's quite the introduction. Let me see if I can get some slides up here. All right. Hope you guys see that.
Yes.
Yeah, thanks, William. I really appreciate that. It's quite the introduction, and thanks to everyone for joining me today. As William said, my name is Mohammed Awad. I'm SVP and General Manager of ARM's infrastructure line of business. Interestingly enough, when I was originally invited to do this talk, I was managing ARM's IoT and embedded business, which in some ways is kind of perfect. One of the things that happens is there tends to be a lot of discussion around what the edge is. There's sort of questions about where the edge begins, where does it end? Is it infrastructure? Is it IoT? Is it something else? And rather than spend a lot of time trying to define the edge in that way, I'm going to make it really simple for us. So for today, I'm just going to define the edge as all of the compute in all of the devices that are not in the data center. So it's going to include markets like industrial automation. It's going to include healthcare, supply chain management, for example. And it's going to include devices as diverse as video doorbells, 5G base stations, and even robots. Okay, so that's how we're going to talk about the edge today. Now, many of you have likely heard about all the success that ARM has had recently in the over the last couple of years in the data center. We've been investing in the space for over a decade, but the progress we've made in just the last few years has really been incredible. Every major hyperscaler is now deploying ARM-based servers, and the momentum is rapidly growing. But even though there's been all this talk about ARM in the data center, I need to be really clear. We love the edge. It's been where our ecosystem has flourished for decades. The very diversity of devices that make up the edge and all of their various requirements, that can only be served by an ecosystem as rich as the one we have created with our partners over the years. And because of that, at ARM, we have the privilege of understanding the edge like no other company. We're working with partners across the entire ecosystem and across the edge to understand what is driving its evolution, and that means we understand its future. You see, the future of the edge can be characterized by three simple attributes. First, ubiquitous connectivity. Every device on the edge will be connected, and that connectivity needs to be reliable, affordable, and scalable enough to support massive amounts of data. Second, pervasive compute. As connectivity becomes more reliable, affordable, and scalable, compute will become even more pervasive. It will be deployed all around us, and it will shape itself to support every demand and every constraint. And finally, actionable on-demand intelligence. This really comes down to easily building, deploying, and managing diverse software workloads that are designed to collaborate across multiple compute tiers. So what's really exciting about this is that as we see these three attributes continue to take hold, the edge is going to transform not only the nature of computing as we know it, but it will transform just about every major industry and market along the way. Let's start with ubiquitous connectivity. What I'm talking about is seamlessly connecting every person, device, and machine on the planet. So very early in my career, I had the privilege of working for Bob Metcalfe. Bob Metcalfe is the co-inventor of Ethernet and the co-founder of 3Com. He has a law named after him, which I think is really cool, right? Anytime you get a law named after you, that's cool. Metcalfe's law states that the value of a telecommunications network is proportional to the square of the number of connected users of the system. Basically, the more devices that connect, the more valuable the network is. It's a great way to explain why the future of the edge means that we will be connecting everything. With every connection, the value of the infrastructure, the value of the edge increases. Now, obviously, the world is more digitally connected now than it's ever been. And with the rollout of technologies like 5G, connectivity is accelerating. In the last year alone, the number of 5G deployments has more than doubled. To date, over 210 operators have gone live, and over 115,000 cell sites have been deployed worldwide. There are over 1 billion active 5G connections already. Okay, but why is that important? Well, it's important because with massive bandwidth and ultra-low latency, 5G has the potential to really revolutionize things like intelligent industry, connected cars, and augmented reality. At the same time, it's providing higher throughput connectivity for people around the world. But as we scale to a ubiquitously connected world, we have to remember to do so in the most sustainable way possible. For telcos, energy efficiency is becoming a key part of their rollout criteria. The GSMA actually estimates energy costs are already between 20 and 40%, 20 and 40% of overall network OpEx. But in addition to that, across the globe, people and organizations are finally starting to wake up to the impact that we're leaving on the planet. We have to do better. That's why I was so encouraged with the results from a recent NTT Docomo trial. By running their 5G core on ARM Neoverse-based Graviton2 processors from AWS, they saw a staggering 72% reduction in power consumption. 72%, just by choosing the right compute for the job. For 5G, that type of more affordable and sustainable connectivity, it means the ability to deploy a denser and more reliable network within the constraints that reflect a more responsible stewardship of our planet. The future of the edge will mean ubiquitous connectivity, and the NTT Docomo trial shows there's a clear path to do so responsibly. And that brings us to the second attribute. You see, as connectivity gets better, compute will become even more pervasive. This is a journey we've been on for decades. ARM partners have shipped over 230 billion processors. That's a big number. But what is more amazing is that the rate at which devices ship is actually accelerating. It took the ARM ecosystem 26 years to ship the first 100 billion chips. The next 100 billion shipped in less than 5 years. And last year alone, the ARM ecosystem shipped nearly 30 billion chips. That's a lot of devices. And every one is either generating or consuming data. Billions of PCs, smartphones, and other consumer devices are streaming personalized content. And a huge explosion of IoT devices are looking to provide insight or make context-specific decisions. In fact, the data sphere is growing so fast that IDC estimates it will grow from 33 zettabytes in 2018 to 175 zettabytes by 2025. That's more than 5x growth. Okay, and since I had to look up what a zettabyte is, let me save you the Google search. It's 1 trillion gigabytes. Mind-blowing. But the reality of data at this scale is that it will be impossible to send it all back to a data center for analysis and decision-making. The model we are using today is starting to adapt. It's going to have to. You'll need to make more intelligent decisions at the endpoint, and at the gateway, and at the edge servers, and at every point along the path, from the tiniest sensor all the way into the data center. The entire edge will need more compute to help secure, filter, and analyze all that data. It's going to be a huge challenge. We will have different use cases, different constraints, and different requirements. You just can't have a one-size-fits-all compute solution for the edge. And that's where the ARM ecosystem comes in. The nature of our business model, our technology, and the ecosystem we have built together has all been specifically designed to enable partners to differentiate and optimize compute to fit almost any use cases, all with the best ROI and fastest time to market. let's take machine learning as an example. ML is probably the single most important workload for the edge. It enables low latency decision-making at scale. There are more ARM-based processors doing ML than any other architecture. Together with the ecosystem, we are delivering ML solutions for everything from always-on sensors to high-performance compute and autonomous driving. You can see some of those examples here. Each one started with some core IP from ARM and then was custom tailored to support a specific use case. The future of the edge is one where connected compute is not only pervasive, but incredibly diverse. It will be available to satisfy every imaginable performance, power, and form factor. And the reality is that many of you on the call today, in partnership with ARM, are already working to make it happen. Thank you. And that brings me to the final attribute that defines the future of the edge: actionable, on-demand intelligence. You see, intelligence is all about making decisions. So sometimes that means filtering data, and sometimes it means asking for more information. Sometimes it means passing information along. Sometimes it means taking action. And there are even times when it actually means doing all of those things, probably at the same time, simultaneously. You know, in the end, intelligence is about software. Software that is secure, that is designed to process vast amounts of data, and that can be deployed everywhere, even across compute tiers, in lockstep with other nodes across the network. And this is complicated. The only way that we'll achieve the level of actionable on-demand intelligence, which defines the future of the edge, will be to ensure software leverage and consistency across a massively, massively heterogeneous hardware base. Let me try to make this simple. Developers need to be able to leverage software investment across lots of diverse hardware. That is critical for scale, and it's critical for ROI. Bottom line, we need standards and a unified development flow. And the good news is, we already have multiple initiatives taking hold that are specifically aimed at solving these challenges. Project Cassini is a great example. As I mentioned earlier, every major cloud service provider is now investing in ARM servers. The progress we have made really is amazing. And the neat thing is that all of that investment from all those hyperscalers, it's translating into this rich and rapidly growing software ecosystem. It's made up of operating systems and applications, languages, libraries, tools, and services that have been specifically optimized for ARM processors. Project Cassini makes it so that edge devices based on Neoverse and Cortex-A can easily take advantage of all that software investment. Partners can choose the right hardware for the job without worrying about having to port and maintain a bunch of software for every new platform. Edge platforms, from gateways to smart cameras and robots, can boot Linux and run things like Kubernetes out of the box. There has already been over 60 devices that have gone through the certification process in support of Project Cassini. This includes products from partners like MediaTek, NXP, and Rockchip. And it includes device manufacturers like Lenovo, Advantech, and Raspberry Pi. And then there's Project Centauri for Cortex-M devices. Project Centauri standardizes some key APIs for Cortex-M-based microcontrollers and enables every software vendor and development environment to take advantage of a common software packaging and delivery format that is already supported by over 9,500 microcontrollers and 450 boards. Platform Security Architecture, or PSA, is another great example. Listen, we all know how important but complicated security is. PSA is a framework that can be easily leveraged for securing connected devices. And we have already seen over 100 certifications. And on the development side, there are offerings like ARM Virtual Hardware, designed with that unified development flow in mind. ARM Virtual Hardware enables embedded developers to do things like continuous integration at scale. Continuous integration has long been a part of cloud-native development. But for most embedded developers, building and managing a hardware farm with lots of diverse hardware is just too complex. By leveraging the cloud, ARM Virtual Hardware makes continuous integration for accelerated software development available to traditional embedded developers. And then beyond that, because you don't have to worry about physical hardware, you don't have to worry about jumpers and cables and wires. ARM Virtual Hardware is making embedded development far more accessible to millions of cloud-native developers looking to take advantage of all of that ARM-based compute on the edge. Those developers are looking to develop an end-to-end system, and ARM Virtual Hardware is enabling them to do so. Put simply, ARM Virtual Hardware is actively bringing the cloud-native and embedded development communities together. But if the cloud-native and embedded development communities come together, then I guess we are back at the beginning. What's the edge? I started by defining the edge as everything but the data center. But if we succeed in delivering pervasive compute, ubiquitous connectivity, and on-demand intelligence, where workloads can easily move across boundaries, then the line between cloud and edge blurs. And what we are left with is a secure and seamless compute infrastructure. It will be made of massively diverse hardware and a coordinated software ecosystem that spans everything from the most power-efficient endpoints to the most performant supercomputers. It will be seamless for developers. It will be highly efficient and sustainable. And it will generate insight and value at tremendous scale. The bottom line, in the future, there is no edge. We will have one massive, highly diverse, and ubiquitous compute ecosystem that includes everything from the tiniest endpoint to the largest cloud data center. Our partners, including many of you on this call today, are already working to help deliver on that future. And if you haven't already, then I invite you to join us as we build the future of computing on ARM. Thank you.
Wow, thank you, Mohammed. That's a
Thank you.
Very impressive, yet very concise presentation. Obviously, you have a very well-rounded experience and complete view of the marketplace as you led the infrastructure and before that, IoT line of business. Tell us a little bit more, about your experience and that transition. Like, for example, is anything interesting or even surprising that you learned as you move from one end of the marketplace to another, from the cloud to the edge?
Yeah, super great question, William. My history, I actually started, in infrastructure at companies like Lucent and Nortel, and then did a lot in the IoT space. And then actually, when I came to ARM, I was originally in infrastructure, then I moved to IoT, and now I'm back in infrastructure. So I really have gone back and forth. And I would say the thing that always surprises more than ever now, as opposed to before, is how the two are converging. I think that is so surprising to me. If you look at the challenges with IoT, it's really around how do you make IoT or edge devices look more like a like the data center, right? How do you make the devices easily manageable? How do you make software super portable across all those devices? How do you create a software ecosystem and innovation at the level that we see in the data center. And what's interesting about the data center is what you're seeing more and more of, especially in the last few years, is you're seeing this move away from, general purpose compute, if you will. So it's looking more like those edge devices and those IoT devices where you've got highly specialized compute platforms, whether it's things like AWS Graviton or Alibaba's Eton. Like these servers are, they take core IP from us and then they go off and customize the CPUs to be very specific. And that's not unlike what we saw previously. So I think this move from, general purpose compute to specialized compute in the data center, which is making it look more like IoT. And in the meantime, we've got IoT and edge, which is trying to look more like the data center in terms of manageability and software. So I think that, if anything, is probably what I found most interesting.
Wow, that's great. Yeah. So that's they are they are more in common than they are different as they move on.
Absolutely.
Yeah.
Absolutely.
You mentioned partnership quite a few times throughout your presentation. I'm part of a startup called Expedera, and we are honored to be an AI IP partner of your company Arm. What is your advice for IP or solution providers to better leverage the Arm partnership ecosystem in reaching out to the end customers who are looking for the most optimal solutions?
Yeah, so it's really interesting because if you look at our ecosystems, obviously incredibly vast. It really spans a huge number of technology companies, and so we're doing things like making it easier for our ecosystem partners to be able to find each other with like online portals, and we host events, and we and that sort of thing. So the first piece of advice that I can give you is tap into the resources that we're providing. So I think that's the first thing. That's the first piece of advice that I would give you. If you want more data on that, you can reach out to me and I can put you in touch with the right people so you can really get, and that goes for anyone on the call, feel free to reach out and I'm happy to make those introductions. So I think that is one important part of the story. And I think the second thing is, leverage the ecosystem. So being part of the ecosystem, I think sometimes people come to it and they say, hey, Arm has this great ecosystem. I want to provide a solution into the ecosystem. And that's only a part of the story, because I think a lot of what you can get with Arm is you can leverage, other aspects of the ecosystem. Nobody, including us, including the largest technology companies in the world, have everything. And I think the value of the Arm ecosystem, not unlike Metcalfe's law, right? The more that we bring to the table, the more partners in that ecosystem that are working together directly, the stronger that is for the ecosystem, but the more that each individual member of the ecosystem can get out of it. So the second piece of advice I would give you is tap into the ecosystem for areas that you're looking to kind of expand your business, right? Beyond just even customers, just in terms of building products and solutions.